Right, this is the twin primes conjecture. There are some prime numbers that are only 2 apart, so 11 and 13, 17 and 19, for example. So the 2 numbers apart, you see, and there's meant to be infinitely many pairs of these as we go forwards throughout the sweep of numbers, basically. So imagine that we're going forward in the positive sense, like 1, 2, 3, 4, 5, 6, 7. That kind of positive sense is what I'm saying, okay? Right, there's supposedly infinitely many twin pairs, excuse me. It said prayers then. Twin pairs of primes, okay? So the further forward we go, we get more and more twin primes, basically. And apparently there's infinitely many. So the word infinity means so big that it can't possibly be counted. In this context, it might as well mean forever and ever ad infinitum, which is the same difference really. And it comes down to a singular statement again, much the same as the Goldbach conjecture, almost identical really, the Goldbach conjecture. Are there infinitely many twin pairs of primes in existence, or are there not? It's a singular statement. Somebody made a singular statement, there are infinitely many twin pairs of primes. And it's up to us to prove a truth or a falsity in relation to this statement. Basically, it's simple as usual. They want one of 2 opposites. That's the answer. One of 2 opposites. But you also know already that there's 3 possible potentials to every single question that you could possibly ask. So to speak, there's a neutral potential and an opposite to any singular potential we might present, you see. So if I say, yes, there are infinitely many twin pairs of primes in existence that are only 2 apart, somebody else can say, theoretically there isn't, theoretically there's an opposite answer for that, plus neutral. I mean, I don't even know what to say anymore about really, that's the thing, I'm trying to flesh this out a bit and say, oh well, actually this, actually that. But in reality there are 3 potentials to everything, and I really don't see that I can put it as any more simple really, simply, pardon me, than that really. I mean, like this, I suppose this is why I haven't made any videos for a bit, I don't know, perhaps it is, but all these problems, like I say, I mean, I've written the same answer to every single problem, essentially anyway, that there's 3 potentials, whether you like it or not, or you're neutral, there's still 3 potentials, you see, so it's just the way I see it really. Like I say, these twin primes and stuff, and the prime number can be evenly divided by itself and 1, and the further we go forwards, we seem to get infinitely many twin pairs of primes. It's not actually related to the distributional structure, so it's not in the same way as the Riemann hypothesis, like we've got a pattern that seems to form in the primes. Not in the same sense. It just means there are infinitely many twin pairs of primes in existence, that's it. Are there infinitely many? Are there not infinitely many? Or neutral in the middle? And that's about as simple as I can get it really. I've written about this on protheory.com, there's essays about this, twin primes conjecture and Goldbach conjecture, both together on my forum as well, which is linked to from protheory.com, as I've said before in the Goldbach conjecture video. And like I say, I don't really see that I can get it any more simple really. It's a really interesting problem and stuff in the prime numbers, but I think I have to explain prime numbers better really to really flesh this one out really, because the way I see numbers is extremely simple, as I've said before in other videos, specifically about numbers and about the Goldbach conjecture. All numbers symbolise either 1, singular, the opposite to 1, which is non-singular, or 0, which is neutral. And that's that. Anything, if you think about the fundamental structure of numbers like I just explained, singular 1, the opposite to singular, or neutral, think of them as here. The prime numbers are actually up here, at a higher relative level, because we're talking about being evenly divided by themselves and 1. It could mean an extremely large number or an extremely small number, but it's still the same 3 fundamental potentials running through all numbers, as I've explained before. So any number other than 1 really is just a repeat potential, a repeat symbolism of the same fundamental potentials, in my view anyway. And what I mean by that is you can split up every number greater than 1 really into units of 1. Like I say, you've just got to keep it simple, I think, anyway. I think prime numbers is, I think the prime number definition is too specific. It's not fundamental enough, I don't think. I don't think the prime numbers or patterns in numbers, I think they're interesting, but I do think they're relative and not fundamental enough to explain numbers fully in this context, which is the theory of everything, which means we must account for every possible potential, ridiculous as it may seem, at all times, which is the nature of everything, in my view. Is the nature of explaining everything is explaining every single possible potential that could occur in my imagination, regardless of how silly it seems. Right, I think my camera's just gone dark again. It seems to be doing this a bit. I don't know if the sun's gone behind a cloud or what, but the camera keeps seeming to go dark all the time. I mean, this is, like I say, it's just a bit of a rambling one, but if you want to read a bit more about the twin primes conjecture, it's on protheory.com, under mathematics answers, under pro answers subsection. I'd like to discuss this with people as well, but I mean, I do think it's really simple, you know, in regards to the theory of everything. I mean, if you want to study things relatively, that's fine, like I say, but fundamentally, numbers are 1, the opposite to 1 are neutral, which is 0. I mean, I really do think that it's important to understand this before you start studying mathematics and higher maths particularly, such as the Riemann hypothesis, which deals with prime numbers in its entirety almost. And like I say, I'm rambling on now, so I'm just going to stop the video now, but it's just to show you that I'm still here, I'm still thinking about the primes, numbers, mathematics, everything else, physics. I've got some interesting ones to make and stuff, just drop remote control. But this is it, okay? Pick this up and I'll say goodbye for now, okay?